one is set up as a live broadcast. So when we start the program at 5 o'clock, that will go on air.
Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com.
Welcome, everybody. As the music ends, and before I unmute the rest of the crowd, you are at VUC number 540 on May 8th. Randy, our usual host and esteemed leader, is vacationing in Cuba this week, so this is Michael Graves sitting in. This week we have Tim Panton presenting YoPet, a web application he's developed. But before we do that, I would like to announce or run our normal promotion of some coming events, which include Camellia World in Berlin, May 27th, 29th, TADHack, the Telecom Application Developers Hackathon, the 12th and 13th of June. We have ClueCon, the 3rd and through 6th of August in Chicago, and closing towards the end of the year in October, on the 13th through 15th, we have Digium presenting AstraCon. And now I can unmute everybody else, go to a camera, and welcome everybody. How are you all?
I'm good. You know, it's raining here. We've just had a general election, but other than that, I'm all right.
Excellent, Tim. Good to see Andy and James Bodie in the Hangout. We have a handful, including Carl Fife on ZipDX, joining audio only. So, hey, Tim, YoPet.
Yeah.
Tell us, from the beginning, though, once more with feeling, because there are going to be a lot of people who just don't know what this is or why this is. So let's go back to the
beginning. So I think it turns out to be a tale of four conferences. Oddly, it's not my day job. So it tends to get done as a sort of get driven by me wanting to put something together for a conference or something like that, and so actually it turns out, as I say, to be the tale of four conferences. So let me do a screen share if I can get that working, and if we put that on there, with any luck, you have my slide.
Yes, we do.
Right. So that is actually Gallagher, who is a cockatoo, and the hand is in fact David Burgess's hand, and that is David Burgess's cockatoo. But anyway, so YoPet actually starts out with me being asked to do a talk at Google's headquarters in San Francisco, and just after Google I/O about WebRTC, and I was asked to do a talk on how live coding a WebRTC web app for an HTML5 audience. So I was kind of thinking, well, what do you do? And I was staying with a friend, with David, and or in David's house, and the cockatoo and actually the two other birds are actually very sociable, and they actually really mind if there's nobody there. They get grumpy. They're very visible, very audible, very interactive, and actually they will look at screens, as you saw earlier. So and they get kind of bored when they get left alone. So I thought, hey, well, maybe I'll turn this into a perfect WebRTC joke app. Video calling your pets. So you want a bird UX, something very simple, cheap. No controls, no self-view, because generally birds don't like seeing themselves. They see themselves as rivals. And I went out and I bought the domain YoPet.us to do the joke properly, and I did the talk and made the jokes about seed funding and that kind of stuff. And actually, the weird thing started happening, which was that people started taking it seriously. And so I thought, well, I've got to find out whether actually there is a market here. So I did a little bit of market research, and there are actually 10 million parrots in captivity in the USA alone. So you then ask yourself, well, would anybody buy this? So we went to, Debbie Davis and I went to Dublin to an exhibition, and we had a little stand there showing a very early prototype of YoPet. And we interviewed people about whether they'd use it and what they'd pay for it and this kind of stuff. And we got a shockingly positive response. Not entirely what we were expecting and not the way we were expecting it, but we did get quite a positive response. So we thought, actually, this might be a product. So and then we thought, well, what is it? How would it work? Well, so the idea would be that you would, you'd go to work, you'd leave take your laptop with you, and you'd leave an Android tablet or something cheap at home, and you'd video call your pet to check up how the pet was getting on whilst you were at work. And so what you see from that is that actually you've got two endpoints with totally different needs. The owner's got one set of needs, and the pet's got a totally different set of needs from the same app. And that's actually not that unusual. The phone kind of gives us the impression that all communication is symmetrical, but actually in practice it very rarely is. Real-time communication is often asymmetric, like what we're doing now. So we need to think about designing something that's like that, that's asymmetrical. So in the owner's case, they want to use it anywhere in the world. They want to be able to use their laptop. They want to find it that it's easy and secure. They want good audio and video, and they want to be in control of that experience. But the pet, on the other hand, wants not to log in, not to have a password, not to have to answer the call, not to get prank calls. You want a cheap device so that if it gets chewed, that's not a total disaster, and you want a multi-day battery life. So it's a totally different thing from your laptop. And so then you ask yourself, well, how do you turn that into a product? And as I said, you take an Android tablet, you just use the browser in the laptop. And so I built an HTML5 prototype using Chrome on both the browser and Android to see how it worked and to test it out on a few animals. And some ignore it. In fact, as Michael has comprehensively shown over the last few days, some very relaxed dogs ignore it absolutely completely. And we'll probably have a test of that in a second. And the other thing you want from it is actually security. And this has been kind of topical in the UK recently because there was a website a few months ago which had 20,000 available webcams that were sitting around that weren't supposed to be available, but people hadn't changed their default passwords. So they were showing their kitchens, their gardens, their garages, wherever they happened to have put a webcam. And anyone who happened to know the default password on that brand of webcam could go and look at that. And the website, the Russian website, had helpfully put all those passwords there and allocated them over different geographies, so you could pick webcam in Leicester or whatever. So that security issue was big, and it was to do with the fact that people couldn't be bothered to change the default passwords on webcams. And why would you? Because it's got no keyboard. It's not that easy. And so the other thing is that the old military thinking of a password isn't really appropriate in this context. I don't want a password to talk to my pet. It's my pet. It's my tablet, actually. I shouldn't need to do that. It's about ownership. It's not about permission. It's not about some higher power granting me permission. It's about it being mine. And the other thing is there's an increasing number of internet-connected devices that simply don't have keyboards, and so passwords stop making sense. And so we now come to, chronologically actually, the second conference, and this was about this was over the air in Bletchley Park. In retrospect, giving this specific set of slides at Bletchley Park was foolish, but given the events that have happened since. But Bletchley Park is the original home of GCHQ. So, and where Turing did his original code breaking. So this was a very small 5-minute talk I gave at Bletchley Park about the fact that our society is actually based on the ability to keep secrets. So if you think about things like religion, you're assuming that your priest can be reasonably expected to keep the secrets that you share with them. And the same is true of your medic, and hopefully your journalist. And if we don't believe that professionals can keep secrets, do those institutions still work in the way that they used to, or do we have to adjust them? So you think about the legal profession is entirely predicated on the idea that you can talk to your lawyer about how to run your defense with the assumption that your lawyer is capable of keeping that private. And the same is true of the financial markets. So the financial markets are entirely predicated on the idea that you can control the time of the release of information to make a fair market. And if you stop being able to manage information and keep it secret when you choose to, then the stock markets actually don't work in the way that they used to. So how do you restore trust in secrecy? Well, I'm a geek. I think WebRTC is a good way of maybe at least starting down that road, because it's got some interesting attributes to do with the fact that it's got strong crypto. It's open source, which means that, you know, a lot of eyes on the problem. If there is a hole, hopefully people will spot it. There's multiple independent implementations because it's from a standard from the IETF and W3C. So, you know, there's a reasonable chance that actually you might get something fairly secure out of that. And you know, a billion people already have it, which is kind of nice. So, you know, and millions of web programmers, at least in principle, can approach it and use it, although it turns out to be slightly harder to do. And so that means that any site could be a WebRTC service, which means that the whole thing is decentralized, which becomes important. It is, however, vulnerable to a certain level of attack. It's vulnerable to keyloggers, and it's vulnerable to hidden microphones and rewritten BIOS. So those sorts of attacks, you know, there's no program that's running inside a machine that's not vulnerable to the BIOS being rewritten underneath it. That's not a problem one can solve at this layer. And using perfect forward secrecy, it's immune to retrospective attacks in the sense that just scooping up all the data that goes out over my internet connection isn't enough to allow you to decode it later. Previous versions, particularly if you could go to a certificate supplier and lean on them, you could then take all your scooped up data and retrospectively decode it. With perfect forward secrecy, you can't do that because the keys are ephemeral. But WebRTC is vulnerable to man-in-the-middle attacks, at least in principle. You can have somebody in between the two endpoints, decrypting it, listening to it, and re-encrypting it, and your two endpoints can't necessarily tell as a man in the middle. You have to do some kind of identity assertion to work out whether there's somebody in the middle. And you can actually, WebRTC has one. You compare a couple of strings of digits, and if they match, then there's nobody in the middle. Unfortunately, the string's a bit long. It's this long. Now, ZRTP, and this is where the first conference comes in, which was ClueCon in 2013, where I had a stand-up argument with Phil Zimmerman about this, about whether this was an appropriate way for mass users to verify their cryptography. His ZRTP uses a different cryptographic solution, which allows you to use a shorter fingerprint string, which you can then actually read out to the person at the other end, and they can compare it with over the phone. Effectively, they can compare it and see whether it's what they're expecting, and if it is, then everybody's happy. And they have to check that the person who's doing it isn't an imposter as well. Perhaps. I don't believe anybody actually really does that, but they could. So I decided that, and this was back at Over the Air, I decided that what we needed to do was to find some user-friendly way of doing this in a web way. Take a web way of securing this communication using 32-byte strings. Oh, and these are the credits for the images you saw earlier. And the kitten was my joking suggestion that, you know, maybe the way to do it was to somehow map these 32-byte strings to various kittens. And then you would say, well, my kitten's got blue eyes and 3 white paws, and the other person would say, well, mine's Ginger Tom or whatever. But that was a not entirely practical thing. So in the end, what I decided to do was to do something a bit more geeky, which is QR codes. Now, if I can get this right, we have. Let me see. Now we need to do this in a way that you can see what's going on. So this is a very simple, minimal implementation of YoPet, which is probably now going to. So when you first start YoPet, you browse to this URL, YoPet owner, and it knows that you haven't got a tablet associated with it. So it asks you to do these things. And what that implies is that you need to get your Android tablet and start the YoPet app. So we'll do that. So this is my Android tablet, and I started the YoPet app, and what I get is a QR code, which I then show to this screen with any luck. I'm holding it at a slightly weird angle, but there we go. And the two of them see each other, exchange the cryptographic fingerprint, actually, and now these two are irrevocably paired. They know about each other, and they know that they're not supposed to talk to anybody else. And then at some point later, you browse back to YoPet owner, you click video on, and with any luck, you're dropped into a video call with your parrot or whoever you have available. So it's supposed to be that simple. Switch that off. So it's supposed to be that simple. And with any luck, Michael is going to be able to show you this happening with real dogs. Let me see if I can. If I turn sharing off, you'll get me back, I think, somewhere.
Yes. Yes, okay. And I'll. Okay, so I need to preface this. It has been said in the field of entertainment, at least, never work with kids and animals. And so our dogs, which are 2 Labradors, are in the other room. And I'll give you a perspective of what we're looking at before we do this. It's going to take a moment to get set up properly. So this is our living room, to use the American parlance. There's a webcam set up sort of on a cadenza that is behind the couch, and you can actually see the head of our younger female Labrador who likes to lay on the couch. My wife allows this. It's not a choice I get to make. But in front of the fireplace opposite, you can't see because it's quite bright through the windows and the fireplace is dark. There's a Nexus 7 in a stand, which is its proper dock, and it's paired to my computer. Now, I'm going to give you the full explanation before we try this. Since I've changed jobs 2 years ago, I don't travel so much anymore, so the dogs are always around me. And thus, today, it's unusual for them to be in the house and for me to be back here. I'm on the property, but I'm not in the same building. So this has changed their perspective on life a little bit, where they used to be very anxious awaiting my return when I was traveling a lot. They don't do that so much anymore. So they're a little less stressed out. Now, one thing that I didn't realize until we got into this is I'm going to have to go for a second, Tim, and change the audio device in YoPet because the computer's all wound up and doing the Hangout, and I think YoPet's going to need a different audio device to keep that separate.
So I'll talk about our experience with other animals in the meantime. What we've found is that in general, quite a lot of animals just treat it as something to be completely ignored. Some of them, though, are actually there's a percentage of them actually are really interested, recognize their owner's voice, and go looking and trying to work out how it was that she got stuffed into this little box, and look slightly worried about it. Others are get used to the experience. Oh, now here we go. You can see the tablet that's coming on. Not quite sure what activities are happening now. So it's woken up, and I don't know if you can do the two-way screen share, Michael, so that we can see. Oh, there we go. Yes. So now this is the view from. So you have the YoPet is now restarting over there. You've got the.
Yeah, I had to change the audio device for YoPet, so
okay.
So it was independent of the Hangout, but it should be able to go back there now.
Right. So if we rejoin that call. So now there you go. So without the dogs answering the call, they've had an secure auto answer call, and as an owner, you can check in that they're perfectly happy and relaxed. I think Michael's dogs are actually very relaxed. Ah, no, things are afoot, and somebody's there, but what's happening? Oh yes, we're getting at least some response, although not enough to get up off the sofa, but why would you if you didn't have to? So yeah, you can check that your dog is alive and responding and is awake to the situation, and perfectly happy. So I think that's probably as much response as we're going to get from them. But actually, if you were traveling, oh no, wait a minute, no, things are happening. Other more interesting things are happening, I suspect. But yeah, okay. So I think at this juncture, it's probably safe to assume that they're not going to do anything interesting, but we'll see. What do you think, Michael?
Okay, I think they are not accustomed to interacting with a little light on a little tablet. I think they're looking towards the back door because they know that I'm back here, or they suspect I'm back here. So I think that gives them sort of a different.
That just proves that they know exactly where you really are, and that they're not going to be deceived by this. But as I say, in terms of your ability to check in on them, which is, after all, they're not going to be paying this bill. You are. So it's actually about whether you feel like you've learned how your pets are, rather than whether the pets have enjoyed it or not.
Yeah.
So
when I was traveling, I could see some value in this because during the day, literally, they were home alone. And at that point, I think there would have been a whole lot more buy-in on their part because I'd been gone for hours or days potentially, and my wife was at work, and so that was that.
Yeah. So once I think buy-in is anyway, bite-in or something. But yeah. So it kind of works. It did the thing it's supposed to do. Whether it's something that that the pets actually are interested in using, or the owners are interested in using, I'll only find out by doing some proper marketing and finding out whether how many users can use it. And I mean, just to finish off the notes on that, in order to do it properly, you actually have to build a mobile app that has things like sleep wake, so that the battery lasts all day, that deals with notifications to wake it up. And as I said, tablets are ideal because they're quite robust. And I happen to use a mobile Android web view to do this, so it minimized the amount of coding I had to rewrite. But once we've done that, kind of what else could we do with it? We've got an interesting pairing technique, secure pairing technique there, that might actually have some other uses, as we were kind of alluding to as I was alluding to in the earlier. So what else could we do? Well, perhaps we could fix the internet. There's an argument which says that it's not broken. I mean, and it kind of isn't yet, but it's clear that there are pressures building up. I mean, remembering passwords isn't just a problem for dogs. It's certainly a problem for me. I hate remembering passwords. There are a number of low-value sites where actually I don't bother. I just get them to reissue a new one every time. Every time I use a particular site, I just get them to email me a new password because I can't be bothered. You know, and all other forms of pairing devices that I've seen are extremely painful. That, you know, type these 7 digits that are glowing on your television into your iPad are painful. So I think, you know, if we could come up with a way that doing that was better, which I argue we have, and more secure, I think that's good. And then, you know, although we didn't show it, there's the ability to manage multiple identities. So the way that those fingerprints are allocated is actually unique per site. So my identity for, you know, say Facebook would be different from my identity for YoPet. And I don't have to blur those two unless I want to. And I think the other thing that we have to understand is that mobile is very personal. People feel very kind of possessive about the devices that are in their pockets, and even more so with things like, you know, the watch, you know, iWatch, and particularly so with medical devices. You know, your pacemaker, or even just your, you know, your fitness band. That information is actually quite personal. So if you think about what's wrong with the internet, I mean, it's worth going back to Internet 1.0, which just kind of looked like this. Bunch of servers, bunch of local users, and pretty much the servers did all the interaction between each other, and then they dealt with their local users over, you know, serial lines or whatever. And then what's wrong with that was, well, pretty much any, you know, it's a federated services model, and any clown can send me email. And the server-to-server connections fail to carry strong identity from one end to the other, which means that I have no idea. Provided I can build a server, I can send email to anyone else in the email system, and they've no idea whether I'm faking the from address or not. There's no way to validate that. And encryption was an afterthought, and still not prevalent in email, and it's still only just getting there with HTTPS. And servers needed a fixed public IP address, so there was a sort of big overhead in running a server. You had to be of a certain, you know, there's only a certain number of servers you could run, and da-da-da. So if you look at Internet 2, which is sort of 2010s email, then actually you run a global service like Hotmail or Gmail, and everyone connects to that. And all right, the global service is actually comprised of multiple servers, but conceptually there's one central thing and everybody goes to it. And what's wrong with that, which I'm nicknaming Hub and Spook? Well, the net result of that kind of architecture is that you end up with my smartphone speaking to my thermostat via a couple of servers in Utah, even if I'm in New Zealand. And that makes no sense whatsoever. And there's zero privacy in that. I mean, you know, the big server in the middle is decrypting the traffic, probably in a foreign jurisdiction with a different set of privacy laws or none at all. And there's a huge amount of latency because you're round tripping from, you know, New Zealand to Utah and back. And what's more, big servers are rich targets. So not only GCHQ and the NSA, but actually in 2-3 years' time, criminals will also be doing this. They'll be, in fact, they are. I mean, if you look at who was it who had all those credit cards hacked recently? Target. The reason that worked is that they had central services that you could raid and get everything from, rather than, you know, so having a few choke points makes it really hot, rich targets. So, what's the goal? How might you solve those problems from the Internet 1 and 2 models? Well, you know, what you want is an architecture that's secure, that's peer-to-peer, so you don't have those rich targets. That has a robust and distributed authentication system that's real-time, so we don't get these latency issues, and that's user-friendly, that's actually designed in a way that suits users. So the idea of what you might call Internet 3 would be a peer-to-peer mesh with a strong introduction system. And I'm arbitrarily basing it on WebRTC because, well, WebRTC has everything you need to do that. You know, if you use turn servers in WebRTC, you can get through pretty much any net, any NAT, any firewall that will allow out HTTPS traffic is usable for this kind of WebRTC traffic. It has built-in and mandated strong perfect forward secrecy crypto. It's peer-to-peer. It leverages certificate-based auth, but it doesn't use PKI. I mean, PKI was a hideous management failure that was impossible to manage, again, because it tried to centralize everything. The joy of what this does is it's distributed and heavily distributed, and it's on by default, which is also nice. So, and it does real time. The QR code pairing that you saw, I've actually filed a patent on aspects of that because I think there is a couple of aspects of it that are sufficiently interesting to be worth doing, and whether I'll get that patent granted or not, I don't know. We've jumped through the first couple of hoops, so there's a fair chance. And little known, but WebRTC actually has hooks in it, although they're not heavily used, but for congestion control and queue management, which means that you know, in an increasingly busy internet, one at least has some tools for managing priorities of traffic or managing how traffic gets allocated. And this is the joy of it, it's already in billions of devices. I mean, we're all using it at this instant. And so it's available in Chrome and Firefox and IE soon, and pretty much everywhere else you choose to look, there's code for. So who would use this kind of solution? Well, I think actually pretty much anybody. Anybody might use this, but you start off with applications for real-time apps like YoPet, but also you could imagine you know, YoGranny. So you leave a tablet on the kitchen table and you check in with your elderly relative who can't be bothered with Skype. You say, hey, Gran, I'll be at the table at lunchtime, and when Gran's having lunch, you just drop in via YoPet or YoGran or whatever you want to call it. And then you can look at other things like webcams and securing things like drones and other devices with cameras like that. But then you actually can go further and start saying, well, you know, once you've done that, why don't you distribute social networks in the same way that actually my social network is held on my phone? My aspect of the social network is held on my phone, and it chats with my friends in real time, exchanging information without having to have a big central network, a central server holding all that data and hoovering it up and selling me ads. And then you start looking at, well, the Internet of Things. I mean, maybe that's another place where we could have the electric blinds talking to my boiler over this kind of stuff. And then there's telecoms infrastructure that I was talking to Carl Fife about earlier. You know, the idea that if you're going to have a lot of femtocells that are going to be owned by individuals sitting on the end of various random bits of NAT and various random bits of connectivity, the current solutions of having to log in and use usernames and passwords and currently doing it all over VPNs back to a central hub isn't going to work. But maybe you could build something that was a cooperative 5G cell network based on this kind of technology. You get your femtocell router, you scan it with your iPhone, because it's seen the QR code, your iPhone can then control it, and da-da-da. So there's this sort of, there are actually a lot of applications for this. And yeah, okay, so I'm being absurdly ambitious here. But actually, there's a lot of possibilities, and we don't have to take all of them. We can take some of the smaller steps. You can maybe take a niche like YoPet, make it work there, then repeat the process in a few other niches. The nice thing is that most of the technology is out there, and there's the opportunity to patent a couple of the key components, which is fun. And although, and this is also something I suspect that very few of you know, but one of the apps I wrote quite early on in my career turned out to be I was involved in writing, I didn't write all of it, was so successful that the FTC actually filed a letter on it, and it got divested from its owners, so that there was more competition in the market. So it's not impossible to write something that gets pretty high traction and takes over a market if you're careful. So how big is this market? Well, I don't know. I think it's a big problem that needs solving. Everyone seems to agree on that. There's 1 billion plus endpoints that could use this tomorrow. There's a reputed, although I don't know where this number comes from, but 12 billion IoT endpoints that, at least in theory, could use it in a couple of years. The small cell market's going to be 6 billion in 2016, allegedly, and the 5G market in 2020, goodness knows how big that is. I mean, maybe James can say, but enormous. So one final thing about why I might do this in Europe. Well, kind of all the antecedents for this kind of technology were in Europe. The web was invented in Europe. GSM roaming was invented in Europe. The public use of encryption, the first mass public use of encryption, the GSMA5, the GSMA algorithms were, although they were weak, they were the first ones, and they were promulgated in Europe in order to defend Germany's eastern border with East Germany. And Skype was a European creation. So, we've got a bit of a track record for this kind of thing, at least. Okay, so philosophy. I don't know if any of you have ever read Jane Austen, but one of the amusing things about Jane Austen is her characters are not allowed to speak to each other until they've been, because they're gentlefolk, they're not allowed to speak to each other until they've been introduced by a mutual acquaintance of appropriate standing. And I think this is actually really interesting, a much more natural way of looking at things than permission-based passwords. I think the idea that my electric car charger can speak to my solar panels, provided I've introduced them, i.e. I've introduced them using my smartphone, presumably as a vehicle for it, that gives them permission, that gives them the introduction to speak to each other, and they know what their relationship is between themselves, i.e. they're both owned by me. I think that's a much more natural relationship than they happen to share some passwordy thing over some kind of distinct set of networks and this kind of stuff. And the same thing actually goes for my social and business networks, at least in principle, or between users and visited radio cells. So kind of the key thing here is that users and the things they own are the center of this mesh, and it's not based around the service providers in the middle, it's based around the users at the edge. So what will I do with this? I have no idea, but if I were to push this out, then I think, I'm already doing the YoPet app, and we'd have to make that something you could sell on the App Store. Need to get the UX design much better than it obviously is at the moment. Need to implement at least some IoT prototypes to verify that this was something one could do, and I've made a small start on that. And then I think the key thing that this needs to get further is someone would have to sit down and write a scalable server platform. I have some bits for that, but I don't have the product. It's codenamed Ipsorama because that's actually television, but instead of using Greek, it's Latin roots. The Greek and Latin roots are swapped. So that's the kind of one other thing. Let me stop sharing the screen and show you one of my IoT experiments, which is this thing, which is a little e-ink screen showing, guess what, one of my QR codes. So that's the pitch, that's the story, that's how YoPet got to where it is, and why I've put as much time into YoPet as I have, despite its inability to get two Labradors off the sofa. That's kind of all I really wanted to say, but if anyone's got any questions whilst you're still awake, if you are, then go for it.
Well, let me say that with respect to the Labradors, they've now come out and rejoined me here near my desk, and they're not displeased with it. I think some familiarity is what's called for, because and as I was inquiring with some friends who are not in the technology business, would they like to have a play with this? And what constantly kept coming up was, if the pets in question aren't accustomed to spending time by themselves, then they have a whole different relationship to the injection of some technology into their day. So it's kind of interesting. Anyhow, some folks on ZipDX, Mr. Fife, *6, if you are muted. Carl, you have questions? You get the honor of the first question today.
Wow, first and last maybe. So, most of what I've heard you talk about is, and I may have missed a bit here and there, but most of what I heard you talk about is pet to human. Have you ever monkeyed around with the idea of sort of pet communities? Like, I know animals like to, be with other animals sometimes. Have you played around with that? I mean, do animals respond to interacting?
YoFlock or MyPat.
Yeah.
No, I haven't. One of the decisions I made very early on was that I didn't want the pets to be able to initiate calls. I thought that would just drive me mad. But maybe that's the wrong attitude. Maybe the right thing to do is to allow the parrots to socially visit their other caged friends down the road, and let them interact.
Yeah, or even like, I hadn't even thought of this, but you said, you didn't want the pets to dial out. But I think there could be some really, really interesting, animal behavior research that could be done if a pet owner could be sought out by the pet. In other words, I'm a bird, I'm a cat, and I am looking for interaction, or I'm a dog and I'm a cat and I'm not looking because I'm a cat, and cats are independent and dogs are not, and dogs want to be social, and da 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 da. I think there's some serious. I've never looked at the literature to see what's been done, but I think that's fertile for. Especially like if you could demonstrate that you could teach them through successive approximations that there's social connectivity on the other end of this appliance that they would interface with, that would include screen pecking pads or scratching pads or whatever, and allow animals to build communities. What if you had seven dogs and
don't say that,
they could,
okay? Just don't say that.
No. Just geographically spread around, and you could demonstrate that these two dogs, like each other, but these other two don't. Like, in other words, this dog is lonely. He's looking for connectivity, but he's looking for social interaction. But that dog over there, that dog is a dick. Like, that's a dick dog, and so nobody wants to hang out with him.
Nobody ever dials. Yeah. You know what? I'm actually not interested in that. No, because I know this is terribly kind of geeky of me, but I think it's much more interesting to have my solar panels talk to my electric car. I think there are. Yeah. I think that sort of application of, or actually, what was it? There was the people who aren't Nest. Their thermostats went offline a while ago because their server shut down, and nobody could control their heating anymore.
Yeah.
And because they were going through a central.
That's why I didn't choose a Nest.
Right. But there's absolutely no necessity for, like, you could get all of the benefits without actually having to have a central server. Except that we never really kind of thought about how to do those architectures. Well, we thought about it, we used to know how to do it, and we don't do it anymore. So I think I think that actually
my IP thermostat is a completely standalone device. It has an embedded web server. It needs no outside connectivity, although it can. But I remember researching those and just thinking, like, why are all these damned things connected to the internet? Now you've got correlated risks. If your thermostat doesn't work, you could lose tens or hundreds of thousands of dollars worth of property, and now you're basically taking that whole framework and making it dependent upon, a 2 nines quality type network service. I completely agree with you.
but the answer of why is because you want to be able to do it from your smartphone. You want to be able to control that device from your smartphone. And half the time in the house, your smartphone is going to be on 3G. So although it's physically in the house, network-wise, it's 1,000 miles away.
So let me ask you this: is there any way to to guarantee, or I mean, like IPv6 whitelistability when you're on mobile networks? I mean, can I basically have a static IP on a mobile network? I can certainly have a static IP on a terrestrial network in IPv6, unless I specifically seek out not having it. Well, I know IPs are hierarchical and geographic, so is that a problem?
Well, it kind of, IPv6 sort of half addresses this, but then it drags in, I'm sorry to say this, my internet friends, my friends in the IETF and other places will be furious with me, but it drags in a whole load of interesting security problems as well. We know where we are with NAT and firewalls for IPv4, but IPv6 is a whole new set of things that we haven't really got our heads around yet.
There's something relevant here that I've sort of been pondering and making notes about for maybe a year or more. It's kind of the appification of all this IoT stuff, which is to say, okay, if I'm doing Sky Bell, which is this video-enabled doorbell Mark III, and the back end of it's a hardware device that's on your Wi-Fi or network or whatnot. That's the front end. The back end then, the client is something that's on your smartphone, and that's all. Right? They're deliberately building islands because the startup that's doing this thing wants to narrow the scope of their effort in delivering a product, but so you end up with this thing that is completely an island, underlying the fact that there's probably standard protocols going on there because they don't want to reinvent every wheel known to technology, but they're not interested in any kind of integration. When what might be a better solution. I ended up with a SIP-based gate phone that integrates to our hosted PBX. I'm still reliant on somebody's cloud service because it is a hosted PBX. I could do IP-based dialing and not be reliant on our internet service, but I have that choice, right? And I think somebody should decide, okay, we're gonna solve this thing not by creating an app, although the app is marketable and cool, and that's why people do it, and it narrows their scope of responsibility, but by solving something maybe involving dynamic DNS or something like that, so that the NAT traversal solution that is IPv4 and firewalls and stuff can be addressed in other ways.
But that's kind of what Ipsorama is attempting to do, in that basically it's using that QR code as not only as a security verification mechanism, but it's also an address. And that's the aspect of it that's novel, is that it's the identity of the endpoint is actually the same as its security token. So that means that that you're effectively layering an extra address on top of the fabric of the internet, which is this QR code and the numbers it represents, turns out to be the address of the device that's attached to it, or think of it as being the SIP address of this tablet, of the app that's running on this tablet.
Right.
I've basically layered that on top, but it's a flat address space in effect. So it mimics the IPv6 flat address space model, but it does it in such a way that it runs over IPv4. It does it. It'll run over, in theory at least, over kind of arbitrary sorts of NAT, provided you've got turn servers available. Which, as we discovered, if you don't, then all sorts of bizarre things happen. But if you do, then at least in theory, I mean, I don't know how your devices were connected. Were you still using LTE for that?
Yeah, in fact, in order to make it work, I should come back to some video here. In order to make it work reliably, what was actually happening was my mobile phone, which is on T-Mobile's LTE, was tethering to the tablet, so that the tablet wasn't on my network, and then the client side, the web browser, was on my network. So it was T-Mobile LTE to Comcast Business Class arrangement in the end.
So, but at no point in that process did you put in any IP addresses or configure anything apart from exchanging these two tokens, which, well, that one token actually is in that implementation. So, the idea is that this is creating a flat address space and that it's a secure address space. Now, what you have to layer into on top of that to get the thing that you were talking about is something like what Chris Matthews is doing at Citrix now, which is to have a protocol that understands, an open protocol that can carry these messages around in a way that is app independent and that other apps and other services could layer into. So I think the combination of, and I keep meaning to talk to Chris about this seriously, the combination of Ipsorama with something like his protocol would create what you're looking for. But I simply haven't spent enough time in the IoT space to do the work to be convincing about that, other than a bit of hand waving.
And in reality, my opinion of the IoT space at this point is that it's non-existent, because everything are islands, and Chris has a solution that is growing, but everything right now is an island. There's no difference between what we call IoT today and household or home automation from a decade ago. It's
well, I think at least in theory there is, which is that you can access your thermometer from your smartphone from work. So if you're traveling and you think, oh heck, I read in the news that there's a freeze coming up, I want to turn on the heating at my house, you can do that from your smartphone in the app. Now that's only in the app, so the benefit is geographical dislocation. But you're right, in terms of the ownership of the data and the control over it, it's very much island based, and it's all going through central servers, which for me is the huge weakness.
Mm.
So Tim, you mentioned IPv6 having some issues with regard to there's kind of open questions, and like we know all about IPv4 and NAT and turning all the ways to make that happen. IPv6 is an open, still some open questions. I don't understand what the open questions would be when I think about IPv6, and especially when I think about IoT, and especially when I think about best practices. My implementation of IoT would be everything is ACL whitelisted. Everything is ACL whitelisted, and I've got a policy that says what can connect to what. And once you and it's one thing to say like, oh well, I've got a secret key, and if you have this, and if somebody else is able to acquire that secret key or intercept some bit of information with regard to that secret key, then you can masquerade and impersonate somebody else. But with IPv6, that's much harder, because the addresses are necessarily, in other words, I can't, if I wanted to basically spoof an IPv6 address, in a TCP type connection between you and I would have to own every router. I would have to be in control of every router and every hop along the way between you and I. Which is not practical.
Yeah, yes and no. I mean, you say the IP address would be whitelisted, but what is the IPv6 address of your smartphone?
Well, that's the smartphone thing. That's the part I don't understand. I mean, I know, for example, that in the current implementation of IPv4 over mobile networks, you're essentially relaying through. You have effectively a static address. It's a 1918 address, but it's static, and the reason for that is obviously because IP routing protocols aren't fast enough to keep up with handoffs, and so they have to essentially create an abstraction layer on the entire mobile network. So if that's happening anyway, unless there's some new IP routing protocols that would allow for, really, smart, path optimization using something better than RIP, something better than BGP, you know, then you're doing proxying anyway. You're already abstracting the entire mobile network to solve that problem. So if you're on IPv6, then I would want to maintain that same address anyway, so that I can say, you know, I mean, we're turning up an EDI server for electronic ordering in our systems, and you know, so we use the AS2 protocol, which you know, which is like HTTPS and has a bunch of other interesting things about it, very secure, blah 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 blah. The thing that matters is that common best practice is that everybody who's got an internet-facing AS2 server has whitelisted everybody who can connect to them on their firewall. So like there is no socket that's listening unless your IP address is X, and that's the best practice because go ahead.
I understand that, but so there are a couple of issues which don't. And then that works if you're a server, but I think it becomes a lot weaker if so. Specifically, say for your mobile phone, if you walk into a Starbucks and you use your Android device in Starbucks, the IPv6 that you happen to get will be, at that point, will be Starbucks's. And if you're roaming in Canada, it'll be an IPv6 address from Rogers.
Yeah.
So you don't.
Yeah, right.
Your smartphone has an infinitely, well, not infinite, but in any given year, your smartphone, even if you were really trying, you'd probably end up with 5 or 6 IPv6 addresses. And then the other thing that happens, which is just emerging, is that IPv6 is now allocating temporary IPv6 addresses to avoid being fingerprinted. So if you look at your Mac, it allocates, I think, 3 IPv6 addresses. It allocates one that's associated with the MAC address. It allocates a linked local one, and it allocates one that is not associated with the MAC address. And preferentially, Chrome, for example, uses that one because it stops people from being able to fingerprint my device. And then the third aspect, which I think is even more interesting, is that all of your apps will present the same IPv6 address, so that the ability for people to track and correlate your actions is hugely increased by the fact that you have to, you're making those IPv6 addresses that you're using for Facebook is exactly the same. Your identity, or a layer of your identity verification in Facebook, is exactly the same as it is in LinkedIn or in the poker site or whatever, and that's not an attribute that you want. So, so if you then carry that on into IoT, then you know you're starting to tie I'm trying to think of something totally frivolous, but so the pacemaker controller or the dosage monitor for whatever is using the same IPv6 address. Is whitelisted for the same IPv6 address as your lawn sprinkler, and that's not an attribute that you want to share across multiple platforms, which is why I think one of the interesting things about
say that again. What am I sharing with my lawn sprinkler?
So all of if you whitelist even if you manage to get your phone down to one IPv6 address, right, then you are giving to the lawn sprinkler that whitelist address, and you're also giving it to the dosage monitor on your heart medicine or whatever, and you're giving it to all of these other devices. So you're using one tokeny thing across multiple services. Whereas what's nice about the way that Ipsorama works is that token is unique per service, so that there's no correlation possible across them.
I see. So, but Ipsorama has a central server that's going to be doing those mappings. Is that right? Do I understand that right?
So that depends on the business model. The really nice attribute of having done this is that you can federate it. So you can have multiple, and as many as you like, Ipsorama services that are federated, because what you end up with is you don't care particularly about the path that you've gone through to get from A to B, because you can verify the end-to-end security. So that means that if you walk into Starbucks and you happen to end up using Starbucks' Ipsorama server, then that doesn't matter, provided it federates with everybody else's and ends up federating with yours at home.
I see.
You get the signal through, and then you can verify that that it hasn't been intercepted and that the endpoints are correct by the token. So you get a nice property of being able to federate without having to trust the federation. The only thing you have to do is assume that they will deliver the message, and if they don't, it doesn't connect.
So do I care? I certainly don't want the poker site to know to know that my IPv6 is the same as my Facebook visit. Do I care if my pacemaker and my lawn sprinkler know that a connection is coming from the same address?
I don't know. It depends on how much you trust the people who wrote the software for them. And whether they're selling you ads based on your lawn sprinkling behavior.
I mean, because it's possible, like, so back to your point about having this kind of decentralized versus centralized connections for things that don't inherently need centralization. The thing that comes to mind is that if I have my own /64, or who knows what my subdivision is, maybe I've got a subnet that's larger than that. I've got multiple I've got sort of multiple IPv4 address spaces that I can use to masquerade the addresses of the different things that I connect to. So perhaps people would say, oh, well, look at the /64, that's obviously Carl, versus, but they couldn't necessarily. Yeah, I don't know. I guess I'm just thinking about, could you, given how large the address space is, you could sort of, you could sort of prevent companies from being able to determine that this connection is coming from the same. Yeah.
I think that's certainly possible, but I think it doesn't help solve the other problem about mobility, that you can't, as the internet is currently constructed. Well, as the internet is currently constructed, you don't get IPv6 addresses much of the time. And even when you do, you've got no control over getting yours, except where you run the network yourself. And even then, your home IPv6 address is unlikely to be in any way related to your work one. Right, Andy's waving.
Exactly.
I'm waving back to Andy, and good to talk to them. I'll see them again.
Thank you for joining, gentlemen.
Yeah, we should probably cut that at the hour, and Carl and I can geek for somewhat longer in the adult section.
Indeed.
Yeah.
Well, thank you, Tim, and we will wind this down, and I don't think we'll bother with the post roll. We'll just go to a slide and be done with it.
Gentlemen, I'm going to drop out.
Good to talk to you, Carl.